Hey, good morning, students. And today we'll be working on the extremely powerful algorithm called gradient boosting. And there's often a joke 5 years ago that if you have any Kaggle competition, just simply use a gradient boosting and the like XG boost, right? And then you will automatically win, right? So that is how powerful. And even until today, if you're working on tabular data, all the best algorithm uses a gradient boosting and its variants like XG boost, right? So yeah, so idea is super simple, right? The hypothesis function is still something related, something H0xi plus alpha 1. So this H is basically the classifier, right? So you're still combining a lot of classifier, but each of the subsequent classifier is sequential, right? When you think about ADA boost, each of them is trying to update the weight, but here there's no actually updating the weight. Everything adds up, and eventually it will give you a very good results. So how do we do that? Before we do that, let us also understand the difference between the gradient boosting and ADA boosting a little bit. Firstly, this alpha is all the same. It's just a learning rate, right? So there's no you don't pay more attention to any classifier, right? Each of the classifier adds up will give you good results, right? But the first one would never have an alpha because it's basically a baseline. Like you just predict using the mean, for example, and then you eventually try to fix all the errors, right? So what is the main idea here? The main idea is extremely simple, and because you can see that like Da Vinci said, right? The simplification is the most powerful sophistication, right? This is the same, right? So here we can see that if we want to get the yi, we can get some very stupid error plus some residual, right? Will eventually give you the target, right? So what if, so of course, if you move everything using normal equation, you can 0 is equal to yi minus h0xi, right? So what if I say that once we know the residual, if we can predict this residual, then we will be able to get this y. Am I correct, right? So this is the whole idea about gradient boosting. It's extremely simple. It's a H0, we get the prediction of H0, we can create H1 that predict this residual, right? But of course, H1 won't do a good enough job to predict exactly what's the residual. Then we try to create H1 that can predict the residual of this part, right? And eventually we do it continuously until the residual is small that it will equal to yi, right? So that is the whole idea behind gradient boosting, right? To summarize, it is extremely simple. We initialize some model, and it can just use some mean, right? As a baseline, then we calculate the residual. We try to predict them. Then we let the next model fit the residual. Then we keep doing this until the residual is no longer there, right? It will never be no longer there, but eventually it'll be so small and we can get very close to y. So you can see that this technique is prone to overfitting, right? But of course, when it comes to performance, it's extremely good, right? So let us code this from scratch, and so of course I already prepared some code, right? So here, hopefully I have all these libraries. Is trying to write some dash line. So can I this first and open again? And hopefully all this squiggly lines is gone and they're gone. Great. And now we want to create a function gradient. Right? So that is y minus h. And y minus h is nothing but just this one, right? Which give you the residual, and you want to fit this residual, right? And then you want to create a function. Let us create this function predict first, right? And we can set the learning rate to be 0.1 for no reason. So this learning rate is nothing but this alpha 1 to alpha s. So all this alpha will have 0.1, right? So that is a big difference between this and AWS. And the first F0 is nothing but taking the first model and predict it, right? So this is nothing but this part, right? But the rest of the part will be different, right? Because we sum all of them from model 1. So we take model 1 until the end and predict them and multiply with the learning rate and take the sum. That will give you the boosting, right? And finally, you can return the boosting here. Note that this is I'm currently doing for regression, but when you do the classification is almost the same, but you just take the sign right here, right? Great. So that is the prediction function. Now we can create the fit function. So for the fit function, we can do like that, and these are the number of models trained. And like I said, the first model is nothing but just a very dumb regressor, right? If you're doing classification, you can just do dummy classifier and just use the let's say the mode, right? And that would work fine, right? So that is the power of gradient boosting. You don't really need a very powerful model. Just create very dumb model, but when you add them up, they work super well, right? And when you fit them, right, and of course append, right? Now you get you fit them, right, and then you now append this model train so that you know which model is the first and second and third, etc. Now you can fit all the rest of the models, right? So you can then predict using that. And then you can get the residual, right? So the residual is nothing but this y minus h, right? Then you fit them, right? So you try to let the next model to try to fit this residual, right? And then you append to this model again, right? And you can see that this predict function already take everything, right? So the residual will always reflect the current residual that is using all the models available. This is a residual, and you try to take the next model to try to fix this residual, right? And you append to this model, and finally you want to return this model's train. Great. So yeah, that is basically it for the gradient boosting. So the idea is just trying to predict the residual. And now I think we can try to use the scratchers code that we predict, that we prepared. So here I'm just trying to quickly paste all the code that I prepared. So this is just a diabetes code. And here I'm just preparing some decision tree of just step 1, right? So they are all very weak learner, right? Except the first one, right? Because the first one is always a dummy regressor, right? So the first model is here, right here. But when you fit, you will be using models that is basically the decision tree regressors. And then what do we do is just call the function fit that we have created. And then finally, we just predict. And let's see whether how well we are performing, right? And here we are doing regression. We should do mean square error. And so this one is 2,714, right? which is you can try SVM regressor or regression or polynomial, and I think this is a quite good one, right? So yeah, so I think that gives you a good idea about gradient boosting. Of course, I did not try classification, but you can try to play around, and hopefully you can also make the classification work.